So the previous video which I was recording was for some fault it was not recorded, and um, so I thought of keeping it short to 15 minutes about, and I will do a code workthrough in this. So what it does is it plots axis and reflect it on all three parts. So let's run this. So this is simple. We are drawing the xy axis and we are drawing a point here, and we are reflecting it along the xy axis. So what it is doing is we are plotting here the points, and for reflection along xy axis we will do is we will make the y to x. Now we will go to reflection of triangle. So this part we have done before, similar kind of thing. Now we will see 6. So this is a reflection which I have drawn, and it also uses the same kind of thing. So let's see the code. So it uses the axis and it reflects every line possible. You can try this. The code will be given, and you can also try different kind of reflection with this codes, and we will see this one. This draws multiple plots, and let's see this. So this is literally drawing multiple plots. One is circle, one is cos function, one is sine function, one is this parabola, and this is tan function. So let's see the code. Let's keep the rendering a little bit slower, so faster. So if we do this, the rendering will be a little bit faster, and we can see that this precision has been lowered. So if we increase this, the precision will be much more greater, means the points will be precisely located and more number of points would be drawn. But what we will see is that the plot takes much more time to generate. So we will work through this problem, how it is done. We have imported the necessary libraries. We have done the same thing. We have set the color bit and point size, and we are using a x from minus 5.0 to 5.0 and with a range of 0.01. So we have imported the numpy library. So if we want to import this numpy library, what we will do is sudo pip install numpy. So for this we will get the numpy and it will be installed. So my requirements is already satisfied, so I'm not installing it again. I'm cancelling the installation. So what it is doing is it is initializing an x. It is going from -5 to 5 with 0.01, and we are doing it, we are defining a constant, not constant, this is also a variable, 7 into x square, and y equal to 2 into math.cos x into math.sin x. Now for this we are getting one plot, for this we are getting another, for this we are getting the circular plot, and this is it. You can check the code. I will upload this in GitHub. So this is the plot generated, and I will keep it to 0.01. This will render much more faster, but the precision is not so good. Now we will see another one. So let's render it. So this is an inequality function. It takes much time to render because obviously due to this so since my laptop is not so powerful, it will take time. Hopefully the video doesn't crash again. God knows. Kill the terminal. Python test.py. cdogl1. Yeah, so this is pretty much the inequalities, and we can see that the precision is not so much, but fine. And if we do this, the plot will be much more precise and the area will be much more dense. So since my laptop doesn't have GPU, so we can see that it has been colored. So this is how we can draw the inequality. So it is what it is doing is it is importing the NumPy library. We are doing the same thing, and we are doing this x to the power x square, and here what we are doing is, if this a is less than x cross x, then we are drawing from x to a point. So this is pretty much, so this is it. Now if we draw like this, let's see what it will do. The computation will be much more costly. So this is an inequality with y is less than or equal to x square x cube. So like this we can draw some inequalities with OpenGL. OpenGL is very much useful for inequalities. So this is the code workthrough, and let's test another one. So this is another one, inequalities. It will take time to render. Okay, this is the same one, and let's draw some Lissajous figure. So this I have done before, so I am just making the walkthrough. So for Lissajous figure, what we have used is math. For x we will use math.sint, and for y we will use math.sint and constant a into t plus b. So let's check this. So this is a Lissajous figure. It's drawn, it's kind of a Lissajous figure only. We will see some more cool examples in the next few videos, and please feel free to comment or change the codes according to your experiments to see what changes can occur if you change it. And thanks for watching this video, and stay tuned for more fun videos like this.